Hello students, how are you? Today we will discuss about the squares and the square roots. It is chapter 6 of NCERT Maths Book, class 8. So let us start. Squares and square roots. Already you have known the word square in geometry. Already you have studied. You see, this is a square. You see, it is a quadrilateral and each side is of equal length. Each angle is 90 degrees. So, if it is a unit, it is also a unit, and it is also a unit. So, what is the area of this square? Suppose it is 2 centimeter. So each side is of equal length. So that is side into side. Already we have known this. Side into side. That is the area, because we are determining the area. So side into side. Side means length of the side. Here side means length of the side. So 2 centimeter into 2 centimeter, that is equal to 4 square centimeter or 4 centimeter square, whatever you tell. So it is the area. Suppose I will take a square of side 1 centimeter. So what will be its area? So 1 centimeter into 1 centimeter, that is equal to 1 square centimeter. So area in square unit, only unit you are having the length or breadth, and here in square, both the length and the breadth, they have the equal length or not? Yes. So 2 centimeter into 2 centimeter, that is equal to 4 square centimeter, or you may write like this, 4 square centimeter, or 4 SQ dot centimeter. You may write like this, or square cm. So like this you can write. So now we will take the square of the number, that is unitless. So how will you represent this? You see, just like this, and we will see some interesting results. You see, 1 square, that means 1 into 1, that is equal to 1. So 2 square, that is 2 into 2, that is equal to 4. 2 cube, 2 raised to the power 3, that is equal to 3 square, that is equal to 3 into 3, 9. 4 square, that is equal to 4 into 4. 5 square, 5 into 5, that is equal to 25. So like this, you may do like this. Eight into 8, that is equal to 64. 9 square, that is 9 into 9, that is 81. 10 square, that is equal to 10 into 10, that is equal to 100. And you see, 11 square, that is 11 into 11, that is 121. 12 square, that is equal to 12 into 12, that is 144. Like this. 13 square, that is equal to 13 into 13, that is 169. 14 square, that is equal to 14 into 14, that is equal to 196. 15 square, that is 15 into 15. 16 square, that is equal to 16 into 16, that is 256. 17 square, that is 17 into 17, 289. 18 square, that is equal to 18 into 18, that is equal to 324. 19 square, that is equal to 19 into 19, that is equal to 361. That is equal to 20 into 20, 400. And what you observe, you see, it is a one-digit number. 1, 4, 9, here it is 6, here it is 5, 6, 9, 4, 1, here it is 0, then 1, 4, 9, 6, 5, 6, 9, 4, 1, 0. So, you see the square numbers are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121 like this. But you mark here, what is the unit digit? You see it is one digit number, so in the ones place the digit is 1. And you see in 16, 6, the digit 6 is in the ones place. Here the digit 5 is in the ones place. So you see, we can get 1, we can get 4, we can get 9, then 6, 5, then 4, 1, that is repeated, and you see, we are also having 0 here. And you see, in the ones place of the square numbers, you cannot find the digit 2, that is missed, 3, that is missed, 7, that is missed, and 8, that is missed. So these are the natural numbers. Yes or no? And you see, 2, 3, 7, 8, these 4 digits you cannot find in the ones place of the square numbers, or these are also called perfect square or square numbers. You cannot find. You see 16, there is 6, but you verify it, you check it. You cannot find the digits 2 or 3 or 7 or 8 in a square number. So if you have been asked which is not a square number, you need not to be calculate. By looking at the numbers, you can also tell that this number cannot be a square number. If 2 or 3 or 7 or 8 is present in the ones place of the number, that cannot be a square number. That is to be marked. So it is very much interesting topic, squares and square roots. So suppose m and n are natural numbers. Okay, or you may call it positive integers. And if m is equal to n square, so m is the square number. You see 4 is equal to 2 square, 9 that is equal to 3 square, 16 is equal to 4 square, Here the m is 16, which is a square number, and 16 is 4 square. Square of the number 4. 4 into 4. So here both 4 and 16, they are natural numbers. But m is, in general we can tell m is equal to n square. Both m and n are natural numbers. Then m is a square number, like this. Okay? So let us know the properties of the square numbers. Suppose I am writing 10 here. So this number contains 1 0 at the end. You see how many zeros? 1 zeros. But the square of this number, 10 square, that is equal to 100. So when there is 1 0 of the number and we are trying to get its square, then you see there are two number of zeros. Two number of zeros. You see. So you see, if it is, the number is 100 and its square you can find 100 square, that is equal to. So how many zeros were present here in the number first? You see, 100 contains 2 zeros at the end, and for 2 zeros you see there are 4 number of zeros. Here it is 4. 4 number of zeros. And if it is 1000, and here there is 3 number of zeros, at the end it contains, and you see here it is how many? There are 6 zeros. Also for the number containing 0, that is 3 number of zeros at the end, and when we are looking at its squares, what we are marking? There are 6 number of zeros. 6 number of zeros here. So always you mark here 2, 4, 6, all these are even number of zeros. So even number of zeros are present in the square number. You see, suppose 600. You see how many zeros? Before it was 600 contains 2 zeros at the end, but the square number contains 4 number of zeros. So double of 2, that is 4, double of 3, that is 6, double of 2, this is 4, double of 1, that is 2. So you should know this. And next, the square of an even number. The square of an even number is even, and the square of an odd number is odd. This is most important, you have to remember. So you see some interesting results now. You see, suppose 1, 2, 3, 4, 5, 6, 7, 8 and 9, and you see 1, 9, 2, 8, just to correspond like this, 3, 7, 4, 6, and it is 11. So you see, you make a pair 1 9, it is one pair. 2 8, it is another pair. 3 7, it is another pair. 4 7, and the rest one number is 5. So you see, so interesting phenomenon you see. Suppose a number ends with digit 1 or 9. Suppose we will take 11 or we will take 19. So you see, this number 11 ends with digit 1 and 19 with digit 9. So we have taken here 1 and 9. So you see what happens in case of 11 square, that is equal to 121, and in case of 19, 19 square is equal to 361. So you observe here, if a number ends with digit 1 or 9, here it is 1 and here it is 9, both the digits are placed in the units place, that is in the, they are called the units digit or in the ones place. And the square of those numbers, so these are the squares, and these squares end with digit 1. So if the squares of the numbers end with digit 1, they must have the digit of the number whose square we have taken, that will be ending with digit 1 or 9. Like that you see 2 and 8, suppose 12 or 18. In both the cases you see 12 square, that is 144, 18 square, that is 324. So in the square of both these numbers, 12 it contains 2, 18 it contains 8. That means 12 and 18, these are the two numbers which end with digit 2 and 8 respectively. So 2 or 8. And when we are taking the squares of such numbers, you see what digit comes. Always the square of those numbers end with digit 4. This is very much important, you have to remember. Then come to 3 or 7. So 13, or you will take the case of 17. It is now 13 upon 17. 13 or 17. In both these cases you see 13 square and here we will have to do 17 square, that is equal to 169. And you see this is 289. You see the number was 13. So this number 13 ends with digit 3, 17 ends with digit 7. And when we are doing the square of these numbers, 13 square is equal to 169, 17 square is equal to 289. So square of both these numbers, those numbers which end with digit 3 or 7, but we find their squares ending with digit 9. So this is a relation you will have to remember. And in case of 4, 7, you see, suppose 14 or 7. Sorry, this is 6. Just I have mistaken here. 4, 6 or 16. What happens here, you see? Here it is 4 in the ones place and here it is 6. So both are the unit digits here. So the number ends with digit 4 or 6 when we are taking their square. So 14 square, that is equal to 196, and 15 square, that, sorry, 16 square, that is equal to 256. So in both the cases you see the square numbers end with digit 6. So when the number ends with digit 1 or 9, their square numbers end with digit 1. The numbers with end with digit 2 or 8, their squares or their square numbers end with digit 4. When the numbers end with digit 3 or 7, their squares or square numbers end with digit 9. So 4 or 6, like that, their squares or square numbers end with digit 6. And in case of 5, already you know, if the number ends with digit 5, so its square ends with digit 5. And you can see here, so it is a very interesting phenomenon, and you will have to remember this and you have to interlink this. So you see, when the number ends with 1 or 9, 1 or 9, always you will find their squares end with digit 1. So if the squares, so this is true, this is also true. How? Now when the squares of the numbers or the square numbers end with digit 1, they must have the square root 1 or 9 as the ending digit of the number. Okay? So this is all about. It is a beautiful phenomenon. It is very much interesting. Okay? So we'll go to next. Finding the square of a number. Finding the square of a number. You see, for the smaller numbers, it is very easy to release the square. You see, 2 square is equal to 4, 3 square is equal to 9, 6 square is equal to 36. Suppose 26 square, we do not know it. So, if you multiply 26 into 26, it will be time taking. So, you should know that we may split that number. How? 26 is equal to 20 plus 6. So, we may do like this. Suppose 26 square, that is equal to 20 plus 6 whole square, square of 20 plus 6. That means you see, suppose 5 square, that is equal to 5 into 5. Like this, you do, it is in the bracket, so you take it twice, then multiply. Okay, and you apply the distributive property of multiplication over addition. You see, 20 into 20 plus 6 plus 6. You may give the multiplication sign or may not. Suppose there is a number and the bracket starts here. So if no sign is here, sign of operation, basic sign of operation, so you will consider it as multiplication. Already I have shown here. So that is equal to 20 into 20, that is 20 square, that is 400 or not, plus 20 into 6, that is 120, plus 6 into 20, 6 to 12, then plus 10, plus 6 6, that is 36. So that is equal to, you see, if you go on adding, okay, you will see, suppose 400 plus 120 plus 120, that is 240. So 400 plus 240, that is, then 36, you see, 676. Am I right? Yes. We may also release like this. We should know this process, how to get it, how to solve it. Okay? Suppose you consider a 2-digit number. It may be 3-digit number, but we will take it now. Suppose 35. And we will do its squaring. What is the value of 35 square? That means 35 into 35. You see, in this number 35, 5 is in the ones place or not? So, you make 5 square, that is 25. And here it is 3. The rest digit is 3. Only 3. So, what is the successor of 3? What is the just after number of 3? That is 4. Next to 3 is 4. So, you multiply 3 by 4. That is 12. So, you write here 12. So, this is the result we got here. And you see, if you keep this number in 3 places, this is ones place, this is tens place, this is hundreds place. And in 100 place there is 12. How we have got 3 into 4? So that is equal to 3 into 4 hundreds plus 2 tens plus 5 ones. So if I write plus 25. So you see this. So 35 square is equal to 3 into 4 hundreds plus 25. That is equal to 1200 plus 25. That is equal to 1225. But easily, suppose like this, 25 square is equal to dash. So we know 5 square, this digit which is in the units place. If there is 5, so 5 square is equal to 25, you write. And just to the left, you see there is only 2 here. So what is the next digit of 3? If you count 3, so 3 will come just after 2. So you multiply 2 by 3. 2 into 3 is equal to 6. So you write this. So this is the result. And when we multiply 2 into 3, that remains in the hundreds place. You see ones place, tens place and hundreds place. So this is 625. Suppose here it has been given like this 105. We can also implement like this. You see 5 is the units digit. So 5 square, that is 25. And the rest truncated number is 10. So what is the next number of 10, 11? You multiply 10 by 11, that is 110. Yes or no? So this is the result. We will get it. So this is the way you will have to remember. Okay? Now we will know some more interesting patterns. Adding triangular numbers. So we will know what are triangular numbers. We will know that first. Triangular numbers are numbers whose dot pattern can be arranged as triangles. You see, I write some triangular numbers 1, 3, 6, 10, 15. You see the difference is 2 here, here it is 3, here it is 4, here it is 5, then you 6. 15 plus 6, that is 21, here it is 6, difference. Then plus 7, that is 28, and so on, like this. And their dot pattern can be arranged as triangles. You see, beautiful pattern, you see. So let it be 1 dot. Come to 3. You see, we could arrange the 3 dots. It stands for 3 and it is represented as a triangle. So for 6, it is for 3 and for 6. And you see, this is for 6. If you go for 10, just 4 in a row now. You see, 3 plus 3, that is equal to 6 plus 4, that is equal to 10. Like this we will have to proceed. And you see, it is as a triangular, you see the pattern. So these are the triangular numbers. 1, 3, 6, 10, 15. So, note best, the sum of two consecutive triangular numbers, that means 1, 3, 3, 6, or 6, 10, or 10, 15, 15, 21, 21, 28. These are the consecutive triangular numbers. So if you add them, we will get the sum, and the sum of two consecutive triangular numbers is a square number, or it is a perfect square. How? You see, 1 plus 3, that is 4. So you see, 3 plus 6, that is equal to 9. 6 plus 10, that is equal to 16. So 10 plus 15, the sum is 25. You see, 4, 9, 16, 25. These are square numbers or not? So when we are getting all this, now when we are adding two consecutive triangular numbers, the sum is always a square number. We got it. So this is a beautiful pattern. When you added two consecutive triangular numbers, we are getting a perfect square. And we will see through picture, we will understand. You see, here it is 1, here it is 3. I will keep this one. You bring this one to here. You see, it is a square or not? You see, 2 rows and 2 columns. It is a square. And you see, 3 plus 6. I will add 3 to 6. So, 1, 2, and 3. So, this one. It was before this. I added 1, 2, and 3. So 6 plus 3, that became 9. And you see, it is 10. So here this part, this part, this part, this part, this part, and this part. So I have to add 6 to 10. 1, 2, 3, 4, 5, 6. So you see, it looks. It was the previous one. It had been arranged as a triangle with 10 dots. We added 6 more dots. So 10 plus 6, that is equal to 16. So totally you see we have given 16 dots here. And see, 16 is a square number, and also we are getting a square set. All these. So this is about what we got on adding the two consecutive triangular numbers. Okay, so we will move to next pattern. I now erase it. Numbers between square numbers. Numbers between square numbers. So you see how many non-perfect square. How many non-perfect squares or non-perfect square numbers or numbers, simply numbers or non-perfect squares, that means non-perfect square numbers, non-perfect square numbers. How many non-perfect squares or non-perfect square numbers or simply numbers are present between two consecutive square numbers? So we have to know this. That means if see, suppose I will write 1 square, that means that is 1, then 2 square, that is 4. So between 1 and 4, that means between 1 square and 2 square, how many non-perfect squares or how many numbers are present between two consecutive square numbers? You see, it is 1 square, so the number is 1, so square of 1, it is square of 2. So what is the answer? You see, which one is smaller? No, 1 is smaller than 2. So you multiply 2 by the smaller number. The answer is 2. So there are 2 non-perfect squares or there are 2 numbers are present between 1 square and 2 square. You see 1 square is 1, 2 square is 4. So we will write 2 and we will write 3. So you see between 1 and 4, how many numbers are present? These are not perfect squares, these are not square numbers. So 2 is one number and 3 is another number. So the total number became 2. 1 is 2 and the next one is 3. So there are 2 numbers. So like this. You see, suppose 10 square and 11 square. How many numbers are present between 10 square and 11 square? So you see, square of 10, this is square of 11. The smaller number is 10. So you multiply by 2. So 2 into 10, that is equal to 20. How? You see, 10 square, that is 100. 11 square, that is 121. You see how many between, so it will not be counted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 20, then I write here 121, just I erase this one here. So you see, how many numbers? So these are the numbers which are not perfect squares. Because after 10, 11 comes. So 10 square is 100, 11 square is 100. So there is no perfect square, or there is no square number between the two consecutive squares. You see, what are the, how many numbers are there? You see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And you see, we have got the answer here. So it is told, suppose n and n plus 1. So two consecutive number. So n square and square of n plus 1, that is n plus 1 whole square. So what is the difference? We have to find out now. How we got to n? Here there are square of two numbers, two consecutive numbers. If one is n, then the next number is n plus 1. So what is the difference? N plus 1 whole square minus n square. But you do not know the expression of n plus 1 whole square. So you will do like this. N plus 1 whole into n plus 1 minus n square. You see, n whole into n plus 1 and this plus 1 whole into n plus 1 minus n square. That is equal to n into n square plus n into 1 n plus 1 into n, that is n, plus 1 into 1, that is 1. We applied the distributive property here. Okay? And also we are applying the same here. We are applying the distributive property of multiplication over addition here. So n square plus 2n plus 1 minus n square. So you see, plus n square and this is minus n square, they cancel each other. So what is the difference? Difference is 2n plus 1. So difference minus 1. Difference minus 1. That is equal to 2n plus 1 minus 1. That is equal to 2n. So between two consecutive numbers, which was one smaller? Between n and n plus 1, n. So you multiply just 2. So like what we did in 10 square, 11 square. So 10 is smaller than 11. So we multiply 2 by 10. So we got the result 20. So there are 20 numbers which are present between two consecutive squares, here 10 square and 11 square. So let us move to next, and we will know what we are getting adding odd numbers. So we can find interesting result here. You just follow me. Adding odd numbers, that means odd natural numbers, or we may tell positive integers. Natural numbers are also called positive integers. So adding odd natural numbers. So we will see what are the odd natural numbers. If you start counting from 1, you see 1, then 3, 5, 7, 9, 11, 13, 15, and so on, like this. So these are the and so on. So we have to add, and you mark here. You first add two odd natural numbers starting from 1. So 1 plus 3, that is 4. It is a square number. Then you add the first 3 odd natural numbers. This is a square number. First 4. This is a square number. So you go on adding like this in this pattern. So you see what is the sum of the consecutive odd natural numbers or the successive odd natural numbers starting from 1. You have to start from 1. So we have started from 1 here, and we have to add the successive, that means consecutive, that means 1, then 3, then 5, then we cannot jump from 5 to, we cannot skip from 5 to 9. No, not like this. We have to start from 1. You have to follow. Then you go on adding. You see what interesting results are coming. If you go on, you see plus 9 plus 11. You see 36. What we are getting? Square numbers. So what we knew from it? First we knew, you have to remember the sum of the consecutive, or you may tell successive odd, these are odd natural numbers, odd natural numbers is a perfect square. That means that is a square number, perfect square. You see, but you have to, the sum of two consecutive or successive odd natural numbers, it will be better if you write it starting from 1. That is one condition. Starting from 1 is a perfect square. This is true. You start from 1. You may add 2. You may add 3 numbers. You may add 4 numbers or 5 numbers, 6 numbers. As many as in this pattern. But you will have to add the successive odd natural numbers starting from 1. And the sum will be a perfect square. You see here. And the second point you see, when I have started from 1, how many odd natural numbers I have added? Not 2. You see, I have added 2 odd natural numbers starting from 1. So for the sum of first n odd natural numbers, for the sum of first odd natural numbers is equal to n square. You see, here there are 2 odd natural numbers starting from 1, and I have added them. I have got the sum. So what is the sum? You see, how many odd natural numbers? 2. So 2 square is 4. How many odd natural numbers? 1, 2, 3. So 3 square is equal to 9. 1, 2, 3, 4. 4 square is equal to 16. So if I will add first n odd natural numbers, that means I will start from 1 and I will go on adding the consecutive odd natural numbers starting from 1 up to n odd natural numbers, then ultimately I will get, as the number is n, I have added starting from 1, I will get the result n square, because for number 2 odd natural number starting from 1, I have got 4, for 3 I have got 9, for 4, that is 4 square 16 I have got, for n I will get n square. So this you have to mark, this is very much important. So you see here 1 plus 3 plus 5 plus 7 plus 9 plus 11, that is equal to 36. 36 is a square number. Suppose you see it is in the left hand side, and it is in the right hand side, and it is the sign of equality. So you see left hand side is equal to right hand side. So if I subtract 36, okay, from the sum, or if I subtract the left hand side value from the right hand side value, definitely the difference will be 0. Yes, sir? So you see, like suppose x is equal to 5, that implies x minus 5 is equal to 0, or 5 minus x is equal to 0. Okay? So you see here, if I subtract 1, then 3, then 5, then 7, then 9, then 11, I will go on subtracting repeatedly the odd natural number starting from 1, and ultimately I will get the difference 0. You see 36 minus 1, that is equal to 35. So this is the first step. Second step, it is over. 35 minus 3, because I have added them to get this, so I have to take away, step by step I will take away. So 35 minus 3, that is equal to 32. Third step, 32 minus 5, that is equal to 27. 27 minus 7, that is equal to 20. 20 minus 9, that is equal to 11. So 9 is gone, already we have taken out. Then 11, we have to take away this 11. You see, the ultimate difference is 0. So 36 is a perfect square. So if, suppose 27, we have been asked whether it is a perfect square or not. We can do like this. What will you do here? We will subtract 27 minus 1, that is equal to 26. 26 minus 3, that is equal to 23. 23 minus 5, that is equal to 18. 18 minus 7, that is equal to 11. 11 minus 9, that is equal to 2. The next 2 minus 11, no, I am not getting 0 here. So 27 is not a perfect square. And you see, how many steps are involved here in case of 36? You see, 1, 2, 3, 4, 5, 6. And you see 6 numbers, odd natural numbers starting from 1, they have been used. So 6 odd natural numbers starting from 1 we have added to give the sum 36. So from 6 numbers we have utilized how many odd natural numbers starting from 1? Here n is equal to 6. So 6 square is equal to 36. So it is all about the play of adding odd natural numbers, and we already knew the exciting results. Now we will know some more pattern. You see. Suppose 11 square. You see. Here 1, here it is 1, here it is. How many ones are here? The 2. 1, 1. How many ones? The 2 ones. So you write 2 here. So towards right you move towards 1, and towards left you move towards 1. So 121 with the square of 11. 111 square. You see how many ones? The 3 ones, 1, 2, 3, 3 ones are here. So you write 3. Like this, you move towards 1, and also towards left you move towards 1. So this is the result. You multiply 111 by 111, you will get this result. So like this, if you do, you see how many ones? 4 ones. So 4, 3, 2, 1. 3, 2, 1. Like this, you can calculate. It is one pattern. Number 2, you see. Seven square, that is equal to 49. And you see 67 square. Okay? 67 square, and this was 4949. You add 48 for 16. You add, just you place 16 here. 667 square. So you placed another 6. So you see here, the extreme 2 digits, you keep it quiet, the same constant. So 4488 for another 6. You see, you keep the extreme 2 digits constant. So how many 6 here you see? 3 6s, 3 4s, and 3 8s. How many 6s? 2 6s, 2 4s, and 2 8s. How many 6? 1 6, 1 4, 1 8. 2 6s, 2 4s, 2 8s. You see 4, 9. How many 6s here? 4 6s. You place here 4 4s with 4 8s. Like this, we can proceed in this pattern. So, in the next video clip, just we will discuss the exercise question of 6.1 and we will solve it. So, if you have not subscribed this channel, please subscribe this channel. So, wish you all the best. Thank you for watching my channel.